So we're going to review quickly our divisibility rules for numbers, specifically for the rules for 2, 3, 5, 6, 9, and 10. I know there are other divisibility rules, but these are the ones that I'm most interested in. And some of these clearly are going to be familiar enough to you, so we'll brush through them quickly. Others may need a quick reminder, but I think they will also be familiar to you. But that being said, let's just make sure we understand why divisibility rules are important to us. They're helpful to us in terms of determining if numbers are prime or composite. So sometimes a number is big enough we don't necessarily know it's prime right off the bat. So we can apply these rules and see if maybe there are other factors that make the number composite. So don't forget that a prime number has only two factors. Remember, factors are numbers that fit into the number, and those factors are 1 and itself. So as an example, something like 17, its factors are only 1 and 17. So that's what makes it a prime number. Whereas with the composite numbers have more than two factors. And if I take something like, I'm going to keep it simple, something like 6, I know the factors are 1 and 2 and 3 and 6, because I know 1 times 6 is 6, 2 times 3 is 6. So those are all the factors, and that's more than 2, so that makes the number composite. So moving on from here, let's quickly review those. I'll tell you what, we'll go from the bottom up. We know that a number is divisible by 10 because the number ends in 0. So examples of that might be, 30 and 1070 and 1,000,000, 3,000, etc. Those all end in 0. So we know for sure those are numbers that are divisible by 10. I'll tell you what, we'll actually go back up to the top. If we want to confirm a number is divisible by 2, it's because the number is even. And by that, we mean it ends in a 0, a 2, a 4, a 6, or an 8, right? So examples we know there would be something like 24 and 378. Okay, so I think those are very familiar to us. We should also know why a number is divisible by 5, because the number ends in a 5 or 0. So examples of that, 75, 1030, 15,000, 85, etc. So the ones that may require some quick reminding would be the divisibility rule for 3 and 6 and for 9. So the divisibility rule for 3 is because the sum of the digits make a multiple of 3. Now don't forget, sum means to add, and a multiple means that 3 will go into the number. So here's an example. I have something like 153. So if I take the 1 plus the 5 plus the 3, that equals 9. I know, therefore, since 3 goes into 9, 3 goes into 153. Now I can take that same rule and I can apply it to the 9 with one minor adjustment. So a number is divisible by 9 because, once again, we start with the sum of the digits makes a multiple of 9. Now, as it turns out, my example from up above, when I added up, the sum made a multiple of 9, and conveniently I could use the same number, but I'll actually use a different one. So I'll start with the 153. Let's see, I'll change it to 135, and then I'm going to say, let's see, 4, 5. So 13,545. Let's just make sure that I did that right, because if I add 1 plus 3 plus 5 plus 4 plus 5, well, let's see, I knew that was 9 already, and that's another 9, and that gave me 18. And since 9 goes into 18, I know 9 goes into 13,545. Last but not least, I have my divisibility rule of 6, and it will be, in this case, it's just really a combination of the 2 and the 3 rule, which means it's because the number is even, but more importantly, and divisible by 3. So if I do something like 400, let's see, and 12, well, that's not going to do it, because that's 5, 6, 7. Let's do this, 1,412. I know it's even, and I know 1 plus 4 plus 1 plus 2. That's 4, 5, 6. Oh, I'm off by 1. Let's say 2,000. Let's go back. This is what happened. This is what happens when I think on my feet. 2,412. Let's see. 2 plus 4 is 6. 7, 8, 9. So it's divisible by 3. It's even. So that is how we know that the number is divisible by 6. So that is a quick summary of your divisibility rules. Any that you did not remember, hopefully you do now, and we can apply these to testing if numbers are prime, and we can also use, or composite, and we can also use these divisibility rules as we move on with doing least common multiple and greatest common factors of numbers.